All right, I think we'll get started here with the next presentation. Next presenter is Anand Ram. He's from Calnex. He's one of two papers that's going to focus on timing sync, functions and implementations. He is the VP of Business Development and comes to us from California.
Okay, good afternoon, everybody, and thanks for staying around. So for those of you who are very short with time, I've given you a big advantage. I've asked the question, I've given a thesis here and given you the answer on the first slide. So the answer is precision sync. So if you're tight for time, you can leave. That's it, the end of the presentation. So if you would like more details, I would love you to stay and listen. So welcome, everyone. My name is Anand Ram. I work for a company called Calnex. Calnex makes measurement and testing equipment specifically for timing and synchronization. And our involvement with the OCP has been in kind of measuring this topic of precision sync. I'll talk more about the specific work stream within the OCP that looks at this very fundamental and important aspect of networking in the data center world. So today, what I'm going to be covering is you'll hear how precision synchronization can help data centers be more efficient. That's the whole title of this presentation. How can a data center be more efficient? We'll also talk a little bit about some of the real-world examples of deployments that have already happened to deliver this increased efficiency. Some of the things we need to look out for if you're looking at these technologies and topics, and of course, ultimately, why that efficiency will deliver savings and benefits to the bottom and top line. So let's talk about why precision synchronization can deliver efficiency. So let's start with a computer. This is a unit of compute that's fundamentally what a data center is built on. Now, when you have two computers that compute and interact with each other, you have communication between those computers. Again, that happens in a data center environment. What happens then is if you synchronize these two computers in terms of time synchronization, you're actually ultimately able to get these computers to communicate and make decisions faster, because you have the ability to establish things like orders of transactions, right? So if computers are exchanging information with each other, if they're synchronized, they can effectively exchange information faster because there is a smaller window of uncertainty. And also, the greater the precision of that synchronization, the faster the decisions can be made. Again, if you're more closely and accurately synchronized, the window that you have to wait is smaller and smaller, which means you can run faster. And of course, speed and capacity is ultimately what efficiency is about. In a data center, we don't just have two computers, we have millions of them. And they're computing and exchanging information across a data center and across data centers all the time. And again, the concept here is very simply this. If they're all time synchronized to a greater degree of precision, they can exchange information more rapidly. And in fact, the interesting thing about this is the idea of synchronizing computers. There's a YouTube video, and the link will be in the slides that you guys see later on. I won't play it now. But this is a YouTuber that's big in the gaming world. So he looks at gaming platforms, and it's very popular. And he took a project he took the card that was created by this project in the OCP, plugged it into a computer, and demonstrated how timing or time synchronizing that computer could actually ultimately make it way more efficient. And also, in terms of the gaming world, the equalization of things like latencies is hugely important in that world. So his dream was to take this card that the OCP developed and have it in every gaming computer around the world. And so that the uses of time synchronization in the world of compute are manifold. And this is a very interesting example of the work being done in this community, potentially benefiting others. But let's come back to the data center world. So I talked about how precision synchronization, the greater the degree of synchronization, the greater the efficiency that's delivered. One of the challenges today is compute power is great. Computers are actually very fast and efficient. They run at extremely high speeds, and two machines next to each other with nothing else can actually exchange information really, really quickly. However, the challenge here is when you're interacting with each other, you need to establish an order of transactions. And so in the data center world, it is common to actually introduce man-made delays, artificial delays, just to make sure no equipment is getting data from the future, as it were. So, you introduce a delay, and you heard in one of the keynotes yesterday the idea of how much time data sits in networking. Part of that is the networking itself. Sometimes that's also artificial delay that's inserted to make sure no information is received by a machine thinking or from the future, basically. But if you synchronize all the computers in the network, you no longer need that artificial delay. So again, in the data center communication environment today, we can effectively, if we synchronize computers, we can eliminate this source of inefficiency in that environment. So, it all sounds great. How do we do it? Well, it's actually happening. So the Open Compute project has a project called Time Card. The Time Appliance project is the working group, and it created something called the Time Card. And this is an example of delivering microsecond accuracy to any x86 machine. This is the card that you saw in that YouTube thumbnail that I showed you earlier, and it's in that video. It's also on display at the, one of the stands here with Safran. There's many implementations of this time card. It's fundamentally the ability to collect time from GNSS, which is a source of time, a universal source of time signal, and then distribute that time within the data center fabric. And one of the other things this working group has done is create a profile. A profile is a set of rules for how you would deploy this technology inside a data center. And that's been developed within the OCP, and you'll see an example of that in the next slide. But also importantly, this is and has been widely deployed. Meta, of course, the first and referenced implementation of time card being used to deliver microseconds level accuracy to the network interface cards. And I talked about the OCP's role in this. This is the data center profile. So the profile talks about a layer, which is the time card that you just saw, distributed via the data center fabric, via time-aware devices called transparent clocks or boundary clocks. These are just usually the fabric switches themselves with the capability built in, and then down to the server layer, where again, the network interface cards have added this precision timing capability in order to extract that precision time. So this has fundamentally delivered microseconds level precision to the server, which is a long way away from where it used to be. We always had a level of synchronization of computers in data centers. We've always had that. Usually a protocol like NTP, the network timing protocol, is used to distribute that. This is a different class entirely. This is PTP, the precision timing protocol. And so we're moving from a world where computers are synchronized to, say, hundreds of milliseconds, to computers being synchronized to single-digit microseconds, which is a phenomenal step. So you can imagine that's the order of magnitude of increase in efficiency that's delivered by better synchronization across that infrastructure. But the important thing here is, and of course I'll say this because I'm a test equipment company, all of that needs to be tested. It needs to be verified. If you want to move from NTP to PTP, you're talking about measuring networks and network equipment, not just to be able to support hundreds of milliseconds of accuracy, which has been the case for many years, but a switch, a terabit switch operating at high workload, being able to deliver across the ingress to egress single-digit microseconds of accuracy, or tens of microseconds of accuracy. So that's pretty tough. But the good news is that the industry's been working on it for years. The equipment's out there. The time cards available today. The top-of-rack switches supported. The network interface cards all supported. But the important thing is it does need to be tested and verified. And again, Calnex works with the OCP to try and standardize testing and measurement methodology so that there's consistency out there. The other beautiful thing, the other wonderful thing about timing or precision timing in a data center infrastructure is that it enables so many more things. I talked about just enabling efficiency, which is a big bonus of precision timing across the data center infrastructure. But you've just heard today the four presentations about the telco edge, or which fit into something called the telco cloud. Telecoms and mobile network operations effectively running in a data center style infrastructure. And that's a big thing these days. Every mobile operator wants to transform their infrastructure into running off servers in a data center. Any telecoms infrastructure needs precision timing. So if any data center is going to sell a service to a T-Mobile here in Czech Republic, for example, of the world, you need to ensure that the server has microseconds and can deliver microseconds level synchronization, because that's needed by the telecom service. So this is not only being done by data centers to enable their own or increase their own efficiencies, it's also being done because you need it to offer any service to the telco world. Same with broadcast. Broadcast needs synchronization to transport across, and again, broadcast moving to the cloud, which is happening, a big initiative that is happening, needs synchronization on the infrastructure in the cloud, better synchronization. And then there's other things like telemetry. Measuring in the data center is hugely important. You're going to hear talks about measurement and monitoring after this. But the accuracy, the validity of that measurement is hugely important. So again, the more accurately you can measure, the more accurate, the better decisions you can make about things like routing and loading and so on. So again, better synchronization in the infrastructure means better telemetry. And then interesting things like, can we use lower spec components? If we have synchronization, accurate synchronization across the infrastructure, can the components in some of the equipment, like the servers themselves, be lower cost? Because you've got an infrastructure to deliver timing. Again, interesting options to look for in the future. First thing is to deploy this infrastructure. And we believe one of the big drivers for a data center operator is the increased and enhanced efficiency. That's the title of this slide, of this talk. So just to finish off, I talked about the Time Appliance project. Again, the slides will have a wiki with all the information. There's a series of talks going back, I don't know, maybe 2 years about this project, lots of talks on this subject. And then the ITUT, which is the International Telecoms Union, a lot of the stuff I've talked about today has been happening for the last 10 years in the telecoms infrastructure, in the telecoms world. So the methodology and the rules and regulations and all that stuff has been designed and deployed in the telecoms world. So there's no need to recreate all that. We can just map it straight into the data center world. And so the ITUT is another great resource to look at for guidelines and rules on this technology and how to deploy and deliver it. And then the one final thing I'll say is another topic that's being worked on. Everything I've talked about today is about delivering timing from a satellite across the data center fabric to the NIC. So that's how you get microseconds to the NIC. That's not the end of the story. We really want to get timing from the NIC up to the CPU. And that is a big challenge because that's going across a PCIe bus usually. But the good news is there is another technology, and that's for a future talk, called PTM. PTM is a mechanism now that's finally being ratified to take the accurate timing that we're getting on the network interface card in the server and give it to the CPU and synchronize the CPU's clock. Now we're talking, because now it's not just the data center fabric and infrastructure that has accurate time. Every CPU in every server around the world has accurate time. And as the guy from YouTube said, he wants to take that further into every computer in the world. So, exciting times. Appreciate your time. We don't have much time for questions, but I will be around the conference if you guys have any questions. And following me is another talk on this topic, looking at how this technology in the telecoms world is being adapted to move into the data center. Okay, well, thank you very much.
Any questions? We do have a few minutes before we start the next presentation. If not, thank you very much.
Okay.